Hi, this is Hayden. So I'm going to talk about the study of cirrhosis disease stage classification. So let's begin by knowing about our dataset background and features. So our dataset is focused on the patients with primary biliary cirrhosis of the liver. And we collected 424 patients who either participated in the placebo-controlled trial or survival without trial participation. And here are several key features of the dataset. And I classified them into several categories, which are the basic demographics, treatment details, clinic measurements, and presence of symptoms, and also the survival status. Then we did the data preparation. First, we dropped the customer ID and social security number column. By removing these two columns, we can reduce the risk of the data noise. And then step two, I put the screenshot of the number of the missing value in the data set. Then we replace the missing value by zeros. For step three, we encoded the categorical variables. For example, 0 means no cirrhosis and 1 means has cirrhosis in order to ensure no artificial ordinal relationship affect the model performance. And then we handle the skewness. Uh, Before applying the log transformation, we identified the variables with skewness that is greater than 1. Let's move to one of the important steps of data preparation, which is outliers. We use a Taki method and z-scores to detect the outliers based on the RQR. And after identify the outliers, we use the windowization to, limit the extreme values to a certain percentile. After that, I put the heat map of the correlation here. I highlight both positive correlation and negative correlations here. We can see for the positive one, the coefficient of 0.44 between n days and number days and albumin. That means the patients with higher albumin level may have a slower progression of the liver disease, leading to like longer survival times. And for negative ones, which are the negative 0.35 and negative 0.33, there we can see the relation between bilirubin and albumin and between stage and albumin. So that indicates that the lower albumin level and higher bilirubin level might be associated with a more severe disease progression. So let's move to the most important part in my presentation, which is the model chosen. So why random forest is suitable here and why we chose. As we know, random forest handles imbalances in datasets by constructing the multiple decision trees and averaging their predictions. And also it can capture the complex non-linear relationship between features. And here I put the screenshot of the result. You can see the holdout sample test accuracy is around like 64 percent, still needs to be improved. And we can also see the confusion matrix that we can see the true positives 36, true negatives is 18, false positives 17, false negatives is 13. And this distribution suggests that the model is imbalanced in terms of sensitivity, but the accuracy needs to be like improved. After that, we also chose the Picariate. So why Picariate is suitable here? So Picariate like evaluates the several machine learning model and ranking them based on the accuracy, recall, precision, and so on. And here I highlighted the highest accuracy, which is the actual trees classifier, and also it has the highest precision rate, which is about like 66 and 0.29%. After that, here are two sets of cross-validation. So besides recall and F1, the top table has higher values than the bottom one. So we can see it depends on the clinical implications. At the end of my presentation, here I want to like, introduce the pipeline for extra trees classifier here. And we can see the simple imputer like occurs twice. That is used for like handling the missing value. After that is mixing balancer is to like address the class imbalance, and standard scaler is for like normalizing the feature data. And the very last one is extra trees classifier is to do the predictive like modeling. So let me wrap up everything I talked about in my presentation before. So for the key insights, we know that elevated bilirubin level, low albumin, and altered platelet counts were identified as key predictors. And in real life, the model predictive accuracy is to help clinician assess cirrhosis risk and tailor intervention strategies effectively. And also, accurate early diagnosis can let the patients to get the treatment in advance to improve the patient outcome in chronic liver diseases. And meanwhile, predictive modeling can also assist patients who require immediately care, optimizing resource allocation and planning in healthcare systems. And here a reference for my presentation. And thanks for listening.